Hi everyone, my name is Kerstin Gerdes. I'm the Open Innovation Champion for Madison Innovations. And I'm here today with two exciting startups, Sensel and Dycotec, and with the Motherson team. And everyone will introduce themselves once they start their presentation. So let's go right ahead and have a short welcome from our CTO, Timo Schwarz.
Welcome everyone on behalf of the Madison Group. My name is Timo Schwarz and I'm the CTO of Madison Innovations. Along with our customers, at Madison we believe that the interior of the future is connected, intuitive, desirable and attractive. And to achieve this, we understand the importance of working with startups on innovative topics to add to our smart surface offering. During the previous Expo through Startup Autobahn, we presented on two projects related to smart surfaces, including the seamless integration and combination of HMI technology and a sustainable material, plus an interactive force controller. Both projects offered unique and intuitive user experiences. So today we welcome you to join us on the second breakout session on this topic, where we will present on our progress with two ongoing collaborations with Sensel and Dycotec materials for exciting smart surface solutions. Thank you very much for your time and we hope you enjoy.
Thank you, Timo. And with that, I'll give to Samir, who will do a short presentation of the Madison Group. Samir, go ahead, please.
Thank you, Kerstin. So hi, everyone, and welcome to our breakout session. My name is Samir, and I'm Business Development and Product Manager at Madison Innovations in Stuttgart. And I'm going to briefly present to you the Madison Group. So the Madison Group is the 21st largest automotive tier 1 supplier, and we are a global supplier supplying different OEMs in all the continents with over 135,000 employees all around the world. We started with wiring harnesses in 1975, and then we developed our product portfolio with different other kind of products. And we do have three main pillars, if we can say that, but in our portfolio. So modules and polymers, delivering IP, door panels and center consoles. Also the wiring harness business is very important for us, and vision systems with our business unit called SMR, supplying so mirrors, interior and also exterior mirrors. We develop full system solutions. And as said before, we are present all over the world. So please, Timo, if we can switch to the next page. And here you can see our footprint. So we are in all continents, in over 42 countries with over 270 locations. And so originally we are from India, actually. So next slide, please. Yeah, so here a brief overview about our customers. So as said before, we are supplying all major customers in all segments. So entry, mid and premium segment in all the continents. And also we are happy to be here in the platform with our customers Daimler and Porsche at Startup Autobahn. A brief overview about our portfolio again. So cockpit modules, door panels, instrument panels, also exterior applications like bumpers, the mirrors, and also we do decorative parts like scuff plates, for example, and also some mechanical solutions. And finally, I would like to briefly present so Madison Innovations. So Timo, the business divisions. Again, here a brief overview about the different business divisions. Wiring harnesses, vision systems, modules, and polymers. As said before, we are also active in the area of aerospace and having also different lighting and electronic solutions. So this is briefly, these are briefly our business divisions at Madison. And now about Madison Innovations. So you have today members from Madison Innovations. So we are the youngest entity at the Madison Group. We are focused on innovation and we are helping our business units to drive innovation within the group. We build, we connect the dots, as we always say, between our internal business units and also our customers, obviously, and we work very closely with partners, suppliers, and among all startups like today with Sensel and Dycotec. And the main topics we are currently handling at Madison Innovations are advanced lighting with the advanced surface technologies and integration of lighting with them, smart surfaces, which is the topic of today's breakout session. We do also have wireless charging solutions for mobile devices, tablets, and also for light modules, so with different approaches. And sensor integration and HMI is also a topic which we are currently handling at Madison Innovations. So that was it from my side, and I give back to Kerstin. Thank you.
Thank you very much, Samir. So I'm very happy to introduce Richard from Dycotec to you. And Richard, the stage is all yours. Please go ahead.
Thanks, Kerstin. Yes, good afternoon, everybody. So my name is Richard Dixon. I'm one of the founders of Dycotec Materials, and I'm obviously delighted to be here and at this prestigious event and to be working with Motherson. Just to give a little background to the company. So Dycotec is an advanced materials company, and we develop and manufacture a range of conductive, electrically conductive, thermally conductive insulator and overcoatings, predominantly for the printed electronics market. Our core competence is chemical formulation and the development of the manufacturing processes to make those materials in high volume. The project with Motherson used a range of our product portfolio, and Dycotec is really this would be a kind of standard project for Dycotec, where we work with a lot of global corporations, often developing bespoke materials, demonstrating them at prototype scale, and working very closely with our customers all the way from sort of proof of concept to prototype to durability testing, and then from pilot production to mass production. So this would be a very standard type of project for Dycotec. But our end business model is to sell the materials in high volume. If we move on to the next slide, Timo. So we were founded back in 2015, but we've enjoyed some. It's not been easy, but we've enjoyed some good growth over the last 5 to 6 years. And last year we purchased a 21,000 square foot facility in the UK to expand both our R&D and manufacturing. Typical batch sizes for us will be of the order of 25 to 100 kg, and we're currently at about 20 staff and looking to hire and expand the team further. And to go on to the next slide, it gives us an overview of some of the markets that we are currently providing materials. So conductive inks for bus bar structures for areas such as display, smart windows, solar cells, some specialist materials for sensor fabrication, obviously work going on in automotive. One of the big growth areas for us is wearable technology, where we provide a portfolio of stretchable conductive inks, and that knowledge has really underpinned some of our work in some of the emerging areas in aerospace and in mold electronics, and again in mold electronics, where you print the materials at 2D. You then assemble, thermoform, and injection mold, and that's used in a lot of lightweight consoles and displays for automotive. And then just to give a broad overview of our product range, top row is all around the conductive materials we provide, so a range of silver conductors for low temperature substrates and high temperature fired, as well as conductive adhesives, carbon and graphene materials. Copper is an alternative to silver, potentially lower cost, less electromigration. Our screen printable transparent conductive inks were used in the project with Motherson. And then we have a range of non-conductive materials. Again, overcoats were used in the project. And I'll mention the thermal conductivity materials here. We specialize in non-silicone sheet and paste materials, and those products are distributed through organizations such as RS Components and DigiKey. And then finally, some of the more specialist stuff that we're working on, things like stretchable materials, in-mold electronics, and of course, lots of tailored materials going on for specific applications. So I'll hand back to Motherson. Thank you.
Thank you very much, Richard. So with that said, our POC with Dycotec presenting is Oliver. Oliver, please go ahead and show your presentation and what we have done together.
Sure thing. Thank you, Kirsten. And hello, everyone. My name is Oliver Gibson. I'm a product manager for Motherson Innovations and came to work with Dycotec as part of our initiative to develop embedded printed electronics and lighting to create integrated interactive interior surfaces. Sounds like a mouthful, but we are trying to accomplish quite a lot here when it comes to the evolution of smart surfaces. So next slide, please, Timo. Next slide, Timo. Sorry, my energy is just going faster than the slides. Thank you very much. So if we consider the evolution of lighting from traditional indirect ambient lighting, which was used for more functional purposes, to direct feature lighting, and then wide area lighting that we see today, what we're seeing and observing is an evolution within the commodity silo. And if we now look at the next slide, if we start consider HMI and the way that it has evolved from traditional buttons, switches, control towers into full interactive touchscreens to then hybrid systems of touch interactive buttons, specific buttons, depending on whether it's a primary, secondary or tertiary interactivity with the vehicle's cockpit, you're seeing this same evolution within the commodity silo. So it'll be the same supplier groups that are creating this evolution. If we look at surfaces, we see a similar case where evolution from traditional plastics, leathers and walnut veneers from the 90s evolved into lower cost PVC soft touch, evolved into recyclable and environmental, more sustainable type materials across different vehicles and different spectrums. But ultimately, the evolution has occurred within that commodity silo, whether that's a tier one that's producing those surfaces or whether it's the polymer provider contributing as the technology enabler, you're still seeing that evolution occurring within the silo. Motherson is looking to take an approach where we believe that the future for interactive surfaces will be an integrated one. So if we consider the fact that smart surfaces will require evolution, that's okay, you can go to the next one, Timo. Evolutions in both surfaces, lighting, and HMI to be able to create these features, it poses a very interesting innovation challenge, which is something that Madison Innovations has been working on quite closely now for some time. So you have issues when it comes to the lighting permeating whatever A surface material you have, the transmission rate, the efficiency of the light being permeated, the sensor's ability to be transparent to that light so that you have a full response and interactivity with that surface, whether you can get a high fidelity control from that surface, and then what type of surface, whether that's in a module, whether that's in a full door card, whether it's in a full IP panel, etc. The sensor, how large can you make it to be able to have that interactivity function, how much is necessary, etc. For the A surface, you do have the translucency effect, where you still need to meet all the standard interior quality requirements for surfaces, but you need them to have these added benefits in order to produce this well curated and amalgamated product of smart surfaces. And as far as the electronics are concerned, again, we've got to take into account a high rate of efficiency. It has to be low power for your EMC compliance, etc., low latency, and we need it to be have a high level of intercomponent communication, because you might have an interactive surface on the IP and the door panel and the center console, which all need to talk to each other so that the HMI experience is fluid across those smart surfaces. So when we came to talking to Dycotec, if we go to the next slide, Dycotec came to mind when we were considering one element of the innovation challenge. So if we consider the integration concept of bringing HMI, lighting, and sensing array into a singular package, we can walk through a exploded BOM that we think will function. So it begins with an LED matrix as our backlighting. Then we will have an interlayer. Then we'll have our sensor substrate and the sensor matrix itself. So the matrix which is deposited to the substrate. Next. We'll have a backing plate or some form of protective overcoating. And then we have our translucent A surface. I think there should be one more. Yeah. So focusing on the sensor matrix is where we came to talk to Dycotec and wanting to investigate the ability of their transparent coating compared to alternative transparent coatings and inks that are available on the market offering conductivity. So the focus was transmittance level for lighting and the actual surface sheet resistance. So how conductive is their transparent conductive ink as compared to others. If we jump to the next one. Excellent. So the benefits of Dycotec's products were quite apparent from the introduction, and the proof of concept which we've completed to date has been mostly around proving out the printability of their coatings and their adaptation to our capacitive sensing designs. So the intent is that Dycotec is supplying that technology enabler in an improved ink, and then Motherson is producing the rest of that integrated array so that we can generate the full smart surface solution for our OEM customers. Jump to the next slide. Perfect. And so this is an example of the proof of concept which we generated. So on the left-hand side, what you're seeing is a traditional transparent ink, which is conductive, which Motherson had been using. And then on the right, you can see this sample which we created with the Dycotec transparent conductive ink. So we saw a significant improvement in transmission, so an extra 10% of transmission, which when you consider that against the efficiency of the LEDs trying to permeate all the layers of that assembly stack is quite important. And then more critically, we found that we can get a 6 times increase in conductivity across that surface, which impacts our design for a design for the smart surface significantly, because it means that we can have either much larger sensor arrays and operating at a similar efficiency of a smaller one. It means that we can have smaller bus bars and therefore less of a frame around that interactive surface. So the customer, as far as they're concerned, they're going to experience more of that edge-to-edge interactivity. And we're seeing more light coming through, so greater efficiency coming through that assembly stack. So as far as the proof of concept's concerned, printing Dycotec's ink, it's been incredibly successful. Where we've had processing challenges, Dycotec have been incredibly supportive and working with Motherson actively to be able to improve those. I think given the effects of COVID and the ability to travel and be at each other's facilities as these trials are ongoing made it all the more challenging, but Richard and his team did an excellent job of supporting that. So as far as a contributor to the open innovation goes, Richard and his team have done a great job working with Motherson to achieve these results. So we're very satisfied with the product. We have built it into a small desktop demonstrator, which adds the other elements which were shown on the previously exploded BOM. However, the sample hasn't been able to be tuned effectively yet, so we just ran out of time once we completed the proof of concept moving forwards into that. But it's a type of demonstrator that we will see once fully tuned presented at customers, and something that we see moving into the future of center console supply from Motherson. So I think that's my time. So I'll hand back to Kirsten, and thank you all for your attention, and I'm sure we can ask any questions at the Q&A at the end of the session.
Thank you very much, Ollie. Very interesting. So with that, we make kind of a switch and we switch to Sensel, and I hand over to Dean from Sensel to tell us a little bit about the company itself. Go ahead, Dean. Dean, you have to unmute. Dean, we still, yeah.
Yes,
sorry,
Thank you very much. My name is Dean Chang. I'm in the product management team at Sensel. Sensel is a startup based in Silicon Valley. And right now we have about 40 employees. And our primary mission is to build the next generation of human interfaces that can be used in a wide range of applications, such as smart surfaces. So on this slide, you can kind of see some of the key strengths of Sensel. It's not just one technology, it's actually 3 technologies integrated into one solution. And that includes touch, force, and haptics. So when we're talking about touch, we're talking about an experience similar to what you see on your smartphone devices or even your automotive displays. So it's a similar with very high accuracy, low latency type of touch solution. And with a smart surface, what you're really trying to do is get rid of mechanical buttons. And in order to do that, you need to have good force sensing and excellent haptics to kind of complement that and accurately emulate a mechanical click. So it's really, like I said, it's not just one of these technologies, it's actually the combination of all 3 that makes Sensel special. Next slide. So one of the technologies that we've produced is what's called pressure grid. And what pressure grid really is an offering, is a sensor that covers an entire surface. It has a bunch of very small sensors that are spaced 1 millimeter apart in an array layout. And so what it does is it operates by sensing pressure. And the pressure sensing can be on the order of a few grams to maybe 500 grams. And the next slide, we talk about how to apply the pressure grid technology. So from an application standpoint, the pressure grid itself can be either on a flat surface or it can be on a curved surface. It can have various interior materials on top that we talked about in the demo that we're going to show you. It has leather. It also combines within the sensor or the same sensor board a haptic solution with great feedback that works very closely together. And in addition, it overcomes 2 of the big challenges of today's touch products. 1, it works with gloves since it is pressure sensing. And 2, it has a higher level of safety or less false touches because you can pretty much set pressure thresholds as to when a touch is actually felt. Next slide. Oh, go ahead. Next slide. There you go. Okay, great. And then, so what we've also done is we've made it very easy for people to evaluate it. We've developed these touchpad evaluation kits. In fact, this is the same product that Motherson used to integrate into this POC design. You can pretty much take it out of the chassis and integrate the module into your design and pretty much move straight into your POC. It gives you the ability to look at touches, change them. It also gives you the ability to tune the haptics to the way that you want them felt. And it has APIs that allow you to pretty much control the interface and tools that allow you to kind of monitor as you're doing your development process. So that's just a quick view of Sensel. Just wanted to keep it short. And back to you, Kirsten.
Thank you so much, Dean. Very interesting. So we did a POC with Sensel, as Dean mentioned, and Thomas is going to present that to us. Go ahead, Thomas.
Hello. So thank you for coming to this session. I would like to talk a bit about our background in smart surfaces. So again, I just would like to remind again what is our definition of smart surface, which is we're embedding the technology in surface design. So the surface is no longer passive, it actives, it reacts to you, and it communicates with you. So next slide, please. So this is a little bit story about our activities in recent year. So last year, we focused on the buttons and slider. And this year, as my colleague already explained, we have a collaboration with Dycotec to make a transparent sensor, which is good enough for the interaction of the lighting. And this demo is for the Sensel, which is we provide a high precision touchpad, which offers the simplicity in seamless design, a great crisp haptic feedback, as well as glove compatible. This glove compatibility is somewhat important in automotive. Next slide, please. So let's get back, let's a little bit flashback on how the touchpad was and how we think it will change. Please press the space, Timo. So this is the modular design, the touchpad that usually we have inside the car is still modular design. It is multi-touch capacitive touchpad usually. It has some force sensor, has haptic feedback, and it's a very beautiful, great design language. But then if we want to put it to smart surface, where we need to put the sensor underneath the surfaces, then space, Timo, please. So we will have a thin surface, and underneath we need to put sensor metrics. Usually once you did that, then either you need to reduce the resolution or it will not be able to detect your finger. So you need to reduce this resolution and compromise on that. But then space again, please. And haptic actuator is make things more complicated because all energy being absorbed by everything. So we need to figure out what is the best decoupling method here so that the energy will go directly to your finger and not really absorbed by its surrounding. And this seamless smart surface, could you space, please, Timo? Again, please. Yep. So I have explained that because you have this distance, so either you choose sensitivity or resolution. Again, you have this haptic force signal attenuation, and the problem again in the integration. So next slide. And during the startup Autobahn, we met with Sensel, which we found out that it could solve our problems. They're offering a different approach with a high resolution touchpad, which is using a high definition grid of sensors that offer you a true high definition multi-touch, glove compatibility with haptic feedback, and you can put soft surfaces on it. So we decided to evaluate that and test the performance, how it really feels, how the end user feels when it is assembled into automotive parts. Next slide, please. Next slide, please. Okay, great. And this is the outcome of our first proof of concept, which it offers a very seamless, clutterless, yet functional design, a seamless A surface, high sensitivity touchpad. So you will find a great linearity, great resolution with this, embedded with the haptic feedback, and also you can use gloves with it. We will see the movie after this. So, right, this is the movie that will show you how it performs. Unfortunately, you cannot really feel the haptic. So I put that click because that's when the haptic gives the sensation to your finger. So because it is pressure-based, you don't need separate button to make activation. So you just slide your finger, push on its place, it detects that you are selecting that, and your finger wants to know that he is doing the right action. So it gives the feedback to your finger, which makes you feel good. You know that you're selecting it. Your fingers know it. And you see now the sliding action there. So it's also very intuitive because you just bring the cursor there, push it, and slide it, and it will follow seamlessly. And this is how actually the machine see. So you can see that even though it is placed underneath a leather, that it can easily detect your finger, your gesture with multi-finger gestures, and you can see different swipe action in here as well. This offers a new intuitive interaction with your car, controlling the volume, air conditioner, new possibilities that you can think of. This is just showing that multi-finger capabilities. So if, for example, even with 3 fingers, okay, let's go with the glove. With capacitive touch, it is virtually almost impossible to make it happen. You put a surface and glove on top of it. You will lose the resolution significantly. You will lose your finger. But this can handle very easily not only 1 finger, but also 2 fingers as well. Even more if you want, but it's just too much with the gloves. This is just one example of the real action, just to show you that even with glove, the interaction is still the same. You don't feel a difference with your bare finger, even though you're using the glove. So we learned that this Sensel product has a lot of future. So we can offer this seamless product, which will give you another option on the interior design. But still, we understand that we have something to improve. So we need to make this to assure that it will fulfill automotive specification. We need, in Motherson side, we need to find out the manufacturability and durability refinement to, again, make sure that OEM and end user are satisfied with it. And we have to improve the haptic response because there's more complicated integration within the car. And we are planning to do that for our next step with Sensel. Thank you. So again, this is our product. You can see this sleek design, and I will give time back to you, Kirsten.
Thank you. Very interesting, Thomas. So we've seen 2 exciting startups with Dycotec and Sensel, and have seen the POCs we have done. Very interesting. So thanks to the team.